The greatest extinction event in our planet's history didn't end life's story. It rewrote the rules of survival completely. Roughly 90% of all species vanished. Vast, interconnected ecosystems crumbled into dust. Yet, from the silent graveyards of the Permian, a new nightmare stirred. Not dinosaurs, but a terrifying collection of monsters that turned the very concept of survival into a brutal arms race. Predators emerged large enough to treat any landmass as their hunting ground. Reptilian giants engineered river systems into perfect ambush corridors. Oceanic hunters ballooned to sizes that rival modern whales. They belong to a fractured chapter of deep time, a period when all land on Earth was fused into a single, colossal supercontinent. A realm defined by climatic chaos, collapsing food webs, and far too many apex killers competing for the throne. The rulebook for survival shifts violently. Predators solve the identical problem with completely different blueprints. Some bet everything on brute force, others on split-second timing, and a few on the very architecture of their bodies. And for a fleeting moment in geological history, they all operated simultaneously. They clashed, their paths overlapped, and they replaced one another in a chaotic cycle. Before one dynasty grabs the crown, there comes a breathless pause where nothing dominates entirely. This is that precise moment of terrifying equilibrium. Biological data from the Triassic points to severe dryness within the supercontinent's core, combined with wild seasonal shifts driven by a mega-monsoon circulation that likely peaked during this exact period. Moisture gathered on the coasts, but frequently starved the deep interior. Lush humidity close to the shore existed a world away from the hyper-arid wastelands of the center, places where dehydration was a faster killer than any tooth. In the opening, few million years after the Permian catastrophe, another eerie anomaly appears on the record. Scientists call it the coal gap. It's a stretch of time where almost no coal deposits formed at all, a chilling signal that plant communities recovered in agonizing slow motion, failing to immediately rebuild the classic swampy systems. This is the precise pressure cooker that spawned our video today. Dinosaurs exist, but they aren't running the show. In the late Triassic, the planet is infested with predators, and among them are lineages that today exist only as crocodiles or have vanished from the fossil record completely. The world is held together by a brittle, temporary ceasefire that is about to be shattered. In what is now North America, the late Triassic Earth trembled under the footsteps of one of the most awe-inspiring terrestrial hunters of its domain, Postosuchus. Meticulous reconstruction of its skeletal frame highlights a stark divergence. One well-preserved specimen measures roughly 12 feet, while another stretches to a terrifying 18. The same data emphasizes that the limb geometry, especially the hand being dramatically smaller than the foot, implies that walking on all fours wasn't the primary mode of transport. This fuels the hypothesis of a bipedal sprinting machine, at least for a significant portion of its life. Quantitative biomechanics later added nuance. Some datasets lean strongly toward a high-speed, two-legged stalker. Other data paints a more mixed picture, varying dramatically between individual specimens. The fossil record also whispers of a monster via a cervical series from an unusually massive animal. A complete neck assembly, notable for sheer scale. Researchers cautiously note that this particular individual could have dwarfed typical specimens, potentially reaching 23 feet in length. This is a fascinating evolutionary twist. The same species could produce drastically differently sized individuals, implying different ecological roles depending on your size. If you found yourself in the path of this beast, a particularly unpleasant surprise was its dermal armor plating. Material descriptions specifically detail osteoderms aligned in spiked rows along the spinal column. Doesn't make the animal invulnerable, but it provides a decisive edge in violent combat and when subduing massive struggling prey. Geography solidifies Postosuchus as a master of its domain. The The study stresses that this hypercarnivore was one of the dominant terrestrial threats of the era. Its fossils scattered across a vast range from Arizona to North Carolina. Down in the southern sector of Pangaea, buried within the strata of the Ichthyosaur Formation, another stone-cold apex killer roamed, Saurosuchus. A biomechanical deep dive describes it as a massive, four-legged moricate, reaching an estimated length of 23 feet. Critically, even a juvenile specimen possessed a skull comparable in mass to that of a fully grown predatory dinosaur from a much later epoch. The researchers deliberately underlined that the immaculately preserved skull came from a not yet mature individual. This means the adult final form was significantly larger, heavier, and profoundly more dangerous than the fossils we've unearthed so far. In this fight, it's not about a foot race. Its devastating jaws would obliterate an opponent's skeleton with a single bone-crushing bite. In biological tanks like this, the key evolutionary drivers are stability, even load distribution, and a skull structure capable of absorbing extreme shock. The paper directly aligns the skull stress patterns with those of later theropod dinosaurs because, during the Triassic, entirely separate lineages independently converged on the same lethal engineering solutions: blade-like teeth, hydraulic musculature, and brute force. Yet, turning back the clock to just after the Permian extinction, the top predator badge was often worn by the Erythrosuchus. This South African terror is the textbook definition of a big-headed bill. A gargantuan skull, a barrel-like body, 4 squat limbs, and a head so disproportionately massive it swallows the animal's entire silhouette. Scientists emphasize that as a group, Erythrosuchids were pioneers among archosaurs to seize the niche of terrestrial hypercarnivore, characterized precisely by these absurdly large heads. Length calculations fluctuate from just over 13 feet up to 16 feet. Descriptions also point to a semi-erect limb posture, a critical evolutionary compromise between the sprawling gait of ancient reptiles and the more energy-efficient upright stance of future rulers. For the early Triassic, this posture represents a bold claim to the role of alpha hunter in floodplains and waterways. Against the backdrop of these armored behemoths, the earliest dinosaurs remained strictly in the background shadows for millions of years. Paleontologists explicitly categorize the initial dinosauromorphs as small bipedal stragglers, just beginning to probe the chaotic edges of available niches. Speaking of which, one of the known early European theropods from the late Triassic is Liliensternus from Germany. Long, stilt-like legs, a shockingly lightweight chassis, and length estimates hovering around 16 feet. This measurement is based on known skeletons, which may, crucially, belong to an incompletely grown individual. Therefore, the focus is less on absolute maximum size, and more on the projection of a nimble precision hunter navigating a world of heavy artillery. In this sort of competitive pressure cooker, victory doesn't go to a single perfect monster. It goes to a suite of traits: explosive short-range acceleration, economical energy consumption, and the agility to change vectors instantly. In the Triassic, the water's edge was often the razor-thin boundary between sanctuary and sudden extinction. The river wasn't just water, it was a trap waiting to spring. In these arterial river systems, the nightmare took the form of Phytosaurs. These were archosauromorphs converging on a crocodilian silhouette so precisely as chilling. Their calling card? An impossibly elongated snout with nostrils mounted backwards and angled vertically. A textbook signature of more derived Phytosaur design. A skull about 3 3/4 feet long, with a total body length of roughly 19 feet and a mass of up to 1,800 pounds. The submerged body remains unseen, breathing continues silently, and then a catastrophic lunge erupts at the optimal moment. Its violent sequence loops endlessly because seasonal drought makes water the absolute hub of life. During arid spells, every animal, the meek and the monstrous, must gamble on the riverbed. Moving into the more equatorial latitudes of the supercontinent, within present-day North Carolina, we find the Carolina butcher, Carnufex, an early crocodilomorph. Scientists describe it as shockingly oversized for its branch of the family tree. The newly discovered fossil, dating back 231 million years, stretches roughly 10 feet. Scientists highlight the elongated skull texture, a sure sign of densely anchored jaw muscles. But the skull alone isn't the story. The real revolution is the sum of its parts. Hind limbs are long, locked directly under the body, and built purely for forward propulsion. The forelimbs barely touch the ground. This is no longer classic crocodile emblem. It is the terrestrial pursuit predator. Biologists label this some Zeta matter, a hybrid toolpity. For IARN, this is a critical pivot point. The peer-reviewed paper explicitly flags this send the top tier of terrestrial punters in the equatorial belt before the dinosaurs. When all land masses are consolidated into a single continent, the surrounding ocean isn't just a decorative backdrop. It is a fully realized alien universe of its own. Modern geophysical surveys note that the Triassic superocean floor has almost completely vanished, consumed by subduction. Therefore, we must reconstruct this liquid world from indirect ghostly evidence. In the Triassic seas, a new breed of predator materializes. Ichthyosaurs. They are naked, unarmored, and completely unsuited for lazy, shallow water ambushes. These creatures are in perpetual motion, mastery incarnate for long-distance cruising, fully adapted to the pelagic desert. They are among the first marine reptiles to completely cut the cord with land. Some lineages remained modest, but others obliterated those limits. In branches like Asteroid and its kin, changes reach a biological extreme. The skull becomes strangely slender, the teeth diminish. You realize the feeding strategy has gone vacuum. This animal sucked its prey inward, creating negative pressure to inhale soft-bodied cephalopods straight into the gullet. Dinosaurus popularis is estimated at over 65 feet. The Triassic Ocean was already testing the upper boundary of animal size, yet not everything in these waves followed the gentle giant script. Some predators go the opposite way entirely. This beast didn't swallow its prey whole, it carved it into pieces. Enter Thalattoarchon, stretching over 26 feet, emerging roughly 244 million years ago. Each tooth is machined not for crushing, not for filter feeding, but for pure butchery. The attack signature is direct, shocking, and final. This is a macro-predator. It targets large prey, possibly even other Ichthyosaurs. Such forms don't appear tens of millions of years after the apocalypse. They explode onto the scene within a relatively narrow geological window. The ocean recovers fast, and the predator-prey hierarchy reassembles almost instantly. Long before the Triassic ecosystem stabilized, however, some of the most unconventional monsters already existed. One is Helicoprion. For a century, it remained among the most baffling fossils ever found. Scientists placed this buzzsaw in almost every conceivable location. None of these models made biomechanical sense. The paradigm shifted when CT scanning delivered a detailed internal reconstruction. The spiral belonged to the lower jaw, anchored symmetrically along the midline. When the jaw snapped shut, the teeth rotated inward, dragging soft prey deeper into the mouth while simultaneously slicing it apart. Specialized cartilage was mandatory to handle the stress. This is the purest example of a monster betting its life not on mass, but on mechanics. Pangaea was not permanent. Around 200 million years ago, at the Triassic-Jurassic boundary, the first great tectonic rifts began ripping the landmass apart, reshaping coastlines and disrupting climate. These changes didn't just affect the ground, they opened the airspace above it. By this moment, the first pterosaurs had taken flight. The earliest known forms ate to roughly 228 million years ago, and they look radically different from the later giants. Their wings are constructed around a single, hyper-elongated fourth finger, supporting a membrane reinforced with internal fibers. Even at this prototype phase, the airframe is effective, but the animals themselves remain small. One of the earliest examples is Eudimorphodon. It flies low, snaps at small prey, and remains highly vulnerable to bigger threats below. Simultaneously, another crucial shift is occurring, not in the air, but on the dirt. The ancestors of both pterosaurs and dinosaurs were astonishingly minute. One example, Conganapha, stood erect at a height of only 4 inches. This does not signify a genetic dead end. It is a distinct survival strategy. Dental microwear textures on the teeth of this tiny creature point to a diet of hard-shelled insects. Energy is packed quickly, and predatory risk is minimized by sheer inconspicuousness. Some predators go the opposite way entirely. This beast didn't swallow its prey whole. It carved it into pieces. Enter Thalatowakon, stretching over 26 feet, emerging roughly 244 million years ago. Each tooth is machined not for crushing, not for filter feeding, but for pure butchery. The attack signature is direct, shocking, and final. This is a macropredator. It targets large prey, possibly even other Ichthyosaurs. Such forms don't appear tens of millions of years after the apocalypse. They explode onto the scene within a relatively narrow geological window. The ocean recovers fast, and the predator-prey hierarchy reassembles almost instantly. Long before the Triassic ecosystem stabilized, however, some of the most unconventional monsters already existed. One is Helicoprion. For a century, it remained among the most baffling fossils ever found, because only one distinct feature was visible: its teeth. They form a tightly compressed spiral whorl, unlike anything in existence today. Lacking a complete skull, scientists place this buzzsaw in almost every conceivable location. The paradigm shifted when CT scanning delivered a detailed internal reconstruction. The spiral belonged to the lower jaw. When the jaw snapped shut, the teeth rotated inward, dragging soft prey deeper into the mouth while simultaneously slicing it apart. Under such harsh filters, survival isn't dictated by power. It's dictated by reaction time, the art of staying hidden, and sheer endurance. Survival is determined by the capacity to adapt. The supercontinent tears itself apart. The climate flips it to chaos, and whole ecosystems are forced to operate at their absolute thermal and metabolic limits. Many of the world's dominant predators vanish. However, this collapse carves a vacuum. Ecological roles on land suddenly gape wide, and something already alive begins to creep into the emptiness. They are not the most massive animals of their age, but they are fluid in their motion, their diet, and their survival calculus. In a shockingly compressed stratigraphic interval, they transform from background ecological noise into the planet's dominant chord. It is precisely because of this volatile and terrifying world that dinosaurs surged forth, eventually establishing a terrestrial reign that would last for the next 180 million years. When survival pivots on adaptability, the ultimate question isn't about who dominates today, but who is already engineered for the world of tomorrow. In the opening chapter of the Mesozoic, the answer was the dinosaur. A serene, misty morning in the late Cretaceous period. Giant herbivores lumber through a vibrant mosaic of ferns and broadleaf plants. 2 survivors. One staked its future on the air, the other on being too small to notice. This was evolution's first successful bet on powered flight, an airframe effective enough to conquer a new frontier. Meanwhile, on the ground, miniaturization was a different kind of superpower. A quick and quiet path to survival. But their world was living on borrowed time, and time was up. Mountain from the sky. An impact that unleashed the energy of 100 million megatons. The world would never be the same. The shockwave continues its global sprint, laying forests flat in radial patterns visually identical to the aftermath of a nuclear explosion. Even on the opposite side of the planet, the crust vibrates violently. Mountainsides collapse into massive landslides as the impact pulse tears through the mantle. In the shallow marine realm, annihilation arrives just as swiftly. The projectile partially struck the ocean, violently displacing a volume of water so vast it defies easy description. Over the ensuing hours, mega tsunamis, cresting hundreds of meters high, race outward. A mobile mountain range of liquid chaos smashes into the coastlines of the Gulf of Mexico and reaches faraway shores along the North Atlantic Rift. Floodwater obliterates everything in sight, sturging hundreds of miles inland before retreating back to the sea, dragging with it a tangled soup of dinosaur carcasses and upended forests. 10 hours post-impact, massive tsunami train waves are still pulverizing shores thousands of miles distant. Coastlines across the globe are catastrophically reshaped. After the water recedes, coastal geography is unrecognizable. Minutes to hours after the collision, a global rain of fire begins to pour from the firmament. Some predators weren't built for swallowing. They were built for butchery. This is the Latoarchon, a 26-foot macro-predator engineered for one thing, taking down large prey. But power isn't the only path. Meet Helicoprion, a puzzle for a century. Its bizarre tooth whirl was finally revealed to be a devastating slicing mechanism in its lower jaw. Yet, in a changing world, even the most dominant predators can be rendered obsolete. When the environment shifts, their specialized power becomes a weakness. For survivors, they are fluid, in motion, in diet, in survival. It's not about the mass of your muscle, but the flexibility of your programming. It is precisely because of this volatile world that dinosaurs surged forth, establishing a terrestrial reign that would last for the next 180 million years. Even kings are not safe from the ultimate test. 66 million years ago, the ultimate question was posed again. Who is engineered for the world of tomorrow? Some predators don't just hunt, they butcher. 244 million years ago, a new terror emerged, Thalatoarchon. 26-foot macro-predator with teeth built for one thing, slicing through large prey. The ocean's recovery was swift, and its new apex predator was brutal, but the Triassic held stranger monsters. For a century, Helicoprion's spiral teeth baffled science. What was its bizarre weapon? The answer? The buzzsaw jaw. As it snapped shut, teeth rotated inward, dragging prey in while slicing it apart. A masterpiece of specialized evolution. But in a world of rapid change, specialization can be a death sentence. When the environment shifts, survival isn't about power, but adaptability. It was this fluidity that allowed dinosaurs to surge forth, transforming from background noise into the planet's dominant chord for the next 180 million years. But even kings fall. 66 million years ago, the ultimate test of adaptability arrived from the sky. An asteroid impact triggered a global firestorm. For the dinosaurs, the world they were engineered for had vanished in an instant. The question isn't who dominates today, but who is engineered for the world of tomorrow. In the end, even giants must yield to change. The shockwave continues its global sprint, laying forests flat in radial patterns visually identical to the aftermath of a nuclear explosion. Even on the opposite side of the planet, the crust vibrates violently. Mountainsides collapse into massive landslides as the impact pulse tears through the mantle. In the shallow marine realm, annihilation arrives just as swiftly. The projectile partially struck the ocean, violently displacing a volume of water so vast it defies easy description. Over the ensuing hours, mega tsunamis, cresting hundreds of meters high, race outward. A mobile chaos smashes into the coastlines of the Gulf of Mexico and reaches faraway shores along the North Atlantic Rift. Floodwater obliterates everything in sight, surging hundreds of miles inland before retreating back to the sea, dragging with it a tangled soup of dinosaur carcasses and upended forests. 10 hours post-impact, massive tsunami train waves are still pulverizing shores thousands of miles distant. Coastlines across the globe are catastrophically reshaped as the seafloor buckles and giant backwash scrubs the continental shelf clean. Minutes to hours after the collision, a global rain of fire begins to pour from the firmament. A land rarely remains still, with each tremor sending fresh landslides down already damaged hillsides. The planet is quite literally quaking in the aftermath. Modern models have shown the darkness persisted month after month, meaning absolutely no plant could carry out photosynthesis. Once lush, Cretaceous landscapes quickly turned into barren dirt. In a deep burrow, a small, shrew-like mammal survived the hellish fires. It cautiously emerges into the murky dimness, searching for scraps. The tiny navigator scrambles over the massive, cooling corpse of a triceratops, searching for edible grubs among the settling ash, and finds very little. In the distance lies an Edmontosaurus, still technically alive, but barely. Its flesh is cooked, and each breath draws in more particulate soot. Across the globe, the once dominant creatures of the late Cretaceous die out in a cascading mass. By the end of the first few days, the entire surface of the Earth has turned into a post-cataclysmic disaster zone. 66 million years ago, a cataclysmic event shattered the world. The reign of the dinosaurs was about to end. The impact triggered wildfires, tsunamis, and a nuclear winter that blocked the sun for years. On land, the giants fell. The mighty dinosaurs, which had dominated for millions of years, were unable to survive the sudden change. The oceans were not spared. Marine life faced mass die-offs as food chains collapsed and the waters grew toxic. In the darkness, life endured. Some species, like the sea turtle, survived, paving the way for the world we know today. The shockwave continues its global sprint, laying forests flat in radial patterns visually identical to the aftermath of a nuclear explosion. Even on the opposite side of the planet, the crust vibrates violently. A projectile partially struck the ocean, violently displacing a volume of water so vast it defies easy description. Over the ensuing hours, mega tsunamis, cresting hundreds of meters high, race outward. A mobile mountain range of liquid chaos smashes into the coastlines, dragging with it a tangled soup of dinosaur carcasses and upended forests. After the water recedes, coastal geography is unrecognizable. Minutes to hours after the collision, a global rain of fire begins to pour from the firmament. The planet is quite literally quaking in the aftermath. In a deep burrow, a small shrew-like mammal has survived. It cautiously emerges, searching for scraps among the settling ash, and finds very little. In the distance lies an Edmontosaurus, still technically alive, but barely. Within a day or two, this 5-ton herbivore finally dies in the dark, chemically poisoned world. Fungi and molds spread rapidly across the planet, thriving on the endless abundance of decaying organic material. The only visible growth was fluffy white and grey carpets of fungus consuming the world. Weeks pass, and the mass extinction reaches its terrible peak. A massive percentage of Earth's species had been wiped out by the combined forces of fire, darkness, cold, and starvation. By current estimates, nearly 3/4 of all species are gone. The mighty dinosaurs, except for a handful of surviving avian lineages, are no more. Entire families have been erased in what was practically an instant, A dreadful silence reigns over the land. But even in this bleakest timeline, not all life was extinguished. Scattered here and there were the seeds of what would eventually rebuild everything. A few months after the impact, the impenetrable blackness begins to slowly dissipate. Pallid sunlight breaks through the thinning clouds. The asteroid's impact was just the beginning. The real nightmare was what came next. A shroud of darkness enveloped the world, plunging Earth into a deep, alien winter that would last for months. Photosynthesis ceased. Plants withered. The foundation of the food chain collapsed, triggering a global extinction of unimaginable scale. But even in this darkest hour, the process of healing had already begun. Life found a way. Hardy ferns and fungi were the first pioneers, transforming the ashes of destruction into a new, fertile world. Nearby, the charred stump of a cycad miraculously sprouts new shoots from its base. Some forms of life prove resilient enough to regenerate, even after being flash-burned. Slowly but surely, hints of green return to the brown and black landscape. Surviving animals begin to reappear and spread through the nascent post-impact ecosystems. In the absence of giant dinosaurs, small creatures take center stage. Mammals, once secondary players in a reptilian world, now emerge into a world almost devoid of large terrestrial competitors. By dinosaur standards, these survivors are tiny, most of them no bigger than a house cat, and many are mouse-sized. For example, but early Paleocene mammals, like Purgatorius and Mesodma, were already around at the very end of the Cretaceous and managed to survive the catastrophe. Their fossils are found on both sides of the KP boundary. Their small size and flexible behavior helped them survive. They needed less food, could hide easily, and some adapted to eating a wide range of items. Thanks to this, shortly after the dinosaur extinction, these rat-like mammals filled the empty ecological niches. Their descendants include all modern mammals, including us. The undergrowth of a regenerating forest, a rat-sized mammal climbs over fallen logs in search of insects for carne. It finds a beetle nest feasting on the decaying carcass of a triceratops and eagerly devours them. In the wake of mass extinction, some predators didn't just recover, they exploded onto the scene. This is the Latoarchon, a 26-foot apex hunter, a macro predator built for pure butchery. Its survival wasn't just about power, it was about adaptability. Meet Helicoprion, a monster with a jaw unlike any other, a buzzsaw in its mouth, designed to slice through soft prey. But even the mightiest empires fall. 66 million years ago, the ultimate test of survival arrived from the sky. The impact triggered a global cataclysm. An infernal rain of molten rock incinerated everything in the open. The reign of the dinosaurs was ending in fire. The world plunged into an endless winter. The giants, once so dominant, were helpless in this new reality. Their world was gone. In the ashes, a new chapter began. The survivors were not the strongest, but the most adaptable. Small mammals and birds, ready to seize a new world. In the ashes of the cataclysm, life found a way. A single green shoot signaled the start of a new world. With the giants gone, small mammals emerged from the shadows. Their tiny size and adaptability became their greatest strength. They were opportunists, scavenging and adapting, filling the empty world left behind. A new order emerged. A delicate, interconnected web of life, small but resilient. Months later, the world was healing. The sun returned, and with it, a new beginning for life on Earth. These humble survivors were the architects of the future, writing the first chapter of our story. Over time, they will diversify and once again fill Earth with an abundance of life. 66 million years ago, one catastrophic event nearly sterilized our planet. The aftermath of the asteroid that wiped out the dinosaurs was a grim and brutal natural disaster unparalleled in scale. A planetary nightmare that lasted for years. In that time, Earth changed from a lush paradise of giants to a shadow-covered world ruled by fire and ice. And yet, even in the face of near-total annihilation, life found a way to survive and recover. The catastrophe ended the age of dinosaurs, but it also cleared the path for a new evolutionary dawn. Tiny burrowing mammals, resilient birds, hardy reptiles, and amphibians. These unassuming creatures inherited the changed world. In the vacuum left by extinction, they slowly spread and evolved, giving rise to new dynasties of life. During the Paleogene period, Earth itself gradually recovered. Over many years and decades, sunlight fully returned, the climate stabilized, then warmed, and forests began to grow again. Not as they had before, but thriving nonetheless. It had once been the KPG impact scar at Chicxulub, eventually vanished beneath the jungle and ocean, leaving only a thin layer of iridium-rich clay in the geological record as a memorial to that fatal event. In the millennia that followed, ecosystems around the globe regained astonishing complexity, and millions of years later, the descendants of survivors repopulated the rejuvenated planet with new species. The end of one era became the beginning of another. In this cycle of destruction and renewal, we witness the extraordinary resilience of life on Earth. The asteroid's aftermath was unimaginably harsh. Fiery rain from the sky, darkness that froze the world, and an extinction event that wiped out the vast majority of species. But it was not the end of the story. From fragile beginnings, life bloomed again, ultimately leading to the rich and diverse world we know today. And the legacy of that catastrophe lives on to this day in every bird that takes flight and in every mammal that walks the earth, including you and I. If you've journeyed with us to the birth of the dinosaurs and the end of an era, make sure to press that like button and help the Winds of Thought community grow. Support breathe new life into these ancient tales. Thank you for watching and stay curious.